All right, guys, so we're going to start on section 10.3. I had just a few kids ask me questions about section 10.2, which is the parabola. I have not looked at your web-assigned scores yet. I'm going to assume, since there were only a few questions, that the majority of you just got it, because that's all I can do. And anyway, I'm going to look at those scores in the morning. I don't have time to do it today. It was a very busy day, and it was a calculus day, so they're preparing for AP exams. So my focus is solely on calculus on day 2. But we're going to go into 10.3, and if you do still have questions from 10.2, you need to get with me on that because I need to move along. All right, so ellipses, okay? Let's look at what this is. And I'm using your book here in the background so that way I can show you some things. All right, so the formal definition is that an ellipse is the set of all points x, y in a plane, the sum of whose distances from two distinct fixed points, which are called the foci. An ellipse has two focus. It has a focus here and it has a focus there, and those are fixed points, and together they're called a foci. Okay, so the sum of whose distances from two distinct fixed points, the foci, is constant. And I found a little animated deal here to show you what that means. So, you know, if this is your point right here, this is some xy. So the points xy along this curve in the plane, okay, is a set of set of points xy in the plane. That's the points that make up the ellipse. And of course, each point has an x and y coordinate. So if this is my point here, we're saying that the distance from this focus to this point is A, and the distance from this point to the other focus is B, right? And no matter which point I plot or pick along this curve, the sum of this plus this will always be the same. So that's what they mean when they say it's constant, all right? So no matter what, if I add this length to this length, I'm going to get the same number. Maybe it's 10, all right? If I choose this point here and I add this length to this length, I'm going to get a 10. If I choose this point here and I add this plus this, I'm going to get a 10, and so forth, all right? So the sum of the distances from the foci is a constant. It's the same number, all right? And again, we have two focuses, which are called foci, and the foci lie on the major axis, all right? You do not have, you're going to have a major axis and a minor axis, and on the major axis is where the foci lie. So let me show you this, because my picture is terrible. I was trying to put too much information in there, and anyway, just ignore this here. Let's start out with a clean, perfect ellipse, something that I could never attain. So the major axis is the longer axis, okay? And you can think of it sort of, now an ellipse is not a circle. A circle is an ellipse, but an ellipse is not a circle. And it has a center, all right? And the major axis goes through the center, so you can kind of think of it as the diameter of a circle, right? The diameter is the only chord that passes through the center of a circle. So the major axis is going to be the longer of the two axes, and it's going to pass through the center. Just like the minor axis also passes through the center, but this one will be longer, okay? So the major axis is just the longer axis. And by definition, the major axis is the line through the foci that intersects the ellipse at 2 points, called vertices. So this is a vertex, and together they're vertices. So this is the line that passes through both foci. So there's foci here somewhere along this line, because they have to be on the major axis, pass through the foci and intersects the ellipse at 2 points, this point and that point, called the vertices, okay? Likewise, the minor axis also passes through the center and intersects the ellipse at 2 points. Those are also called vertices, okay? The difference is that between the length, so the minor axis is smaller than the major axis, but the minor axis is always perpendicular at the center. All right, it's a chord. If you remember your definitions from geometry, okay? A chord is just a segment that touches 2 points on the circle. And it doesn't go through, generally, the center, except for the diameter. But this is not a circle. So, anyway, the center of an ellipse has coordinates hk, just like the parabola, just like a circle, right? The vertices are located at h plus or minus a, depending on which direction you're moving in the picture, comma k. So you know, this is your x coordinate, this is your y coordinate. And the foci are at h plus or minus c, comma k. Now what's the a and what's the c and what's that all about? This is a very nice picture, and this is why I wanted to use the book. So we have an ellipse with a center at hk. The distance from the center to each focus or foci is called c in this book, always. And the center is the midpoint between both foci. Okay, so this is the midpoint of this segment right here between this focus and that focus. Likewise, the distance from the center to a vertex is called a. All right, so if this is a and this is a, then the whole length of the major axis is 2 times a. All right, and the center is the midpoint of the distance between the vertices. So it's the midpoint of the major axis from vertex to vertex. Likewise, for the minor axis, they call this distance b. The distance from the center to a vertex is b. So the hard thing on this is you're going to have to keep your a, b's, and c's. A and c's are horizontal, and b is vertical. By the way, if you have an ellipse whose center is, say, at the origin, so pretend this is the major axis is on the x-axis and the minor axis is the y-axis, and this point here is 0, 0, and I choose a point somewhere vertically, then since the major axis and the minor axis intersect at 90-degree angles, what I have are 2 right triangles, right? And since this is since this is C and this is B, then by Pythagorean theorem I have C squared plus B squared is equal to this hypotenuse. And we know with the Pythagorean theorem, once we square and sum the legs, we take the square root. So this length here is the square root of B squared plus C squared. You notice this one's the same exact thing. Okay? So, what you need to know is this little table that I posted on Edsby. Now, I crossed this out. Eccentricity is just the roundness or the roundness or the curviness of the ellipse, all right? And you don't need to know that. It's not in your curriculum. What you do need to know is if the major axis is vertical or horizontal. So let me show you that too. Here it is. If the major axis is horizontal, like this, right, we have this formula that we need to know. And if it's vertical, right, it's the longer of the two, then you have to use this formula. And you notice the HK correspond with the center of the ellipse, but you know you've got your A and your B's. And the only difference between these two formulas is that here it's x over b, y over a, and for the horizontal major axis you've got x over a, y over b. So they switch places. All right, that's the only difference between these two formulae. The center is at hk. The vertices are at h, comma k plus or minus a. The foci are h, comma k plus or minus c. Now, these swap around. So these are the hard ones. So the foci here is h, comma k plus or minus a when the axis is vertical. When it's horizontal, it's h plus a, or h plus or minus a, comma k for the horizontal. And see here, the foci is h, comma k plus or minus c, and horizontally it's h plus or minus c comma k. So the k's and the c's switch places in the foci case, and the k's and the a's switch places in the vertex case. The major axis equation, the length of the major axis is 2 times a. Remember that picture with the a, b, and c? So again, back up here, this one, okay? The length of the major, remember if this whole thing is a, it's a, then the length of this is 2 times a. A plus a is 2a, right? B plus b is 2b. So 2b is the length of the minor axis. And then the equation that relates these variables together is Pythagorean theorem, but with a twist. It's not a squared plus b squared equals c squared. You've got to be really careful. It's a squared equals b squared plus c squared. So make sure you're very, very careful with this formula. Okay, and that's just because of the way they're using a, b, and c here. All right, so let's have a look at an example, because the big thing you're going to have to do is, given some information, you're going to have to write the equation of the ellipse. So here's an example here. Now, they're going to give you a little bit of information, maybe a sketch, and what you're going to have to do is take that information and perhaps make a sketch and put all the pieces together. All right, so I'm going to try and keep this little, let me just move my camera out a little bit. So I hope this doesn't come out as weird as it's looking right now as I'm recording it, but anyway, this chart kind of looks blotchy in the video. Anyhow, this is what's given. It says find the standard equation of the ellipse with foci at 0, 1, 4, 1, and a major axis of length 6, right? As shown in the figure. So they're giving you the figure. Okay. So again, what I would do, or how I would think about it, is like this. First, I would plot my foci. At the point 0, 1, I have a focus. And at the point 4, 1, I have another focus. Now, what do I know? I know that the foci lie on the major axis only. So I know my major axis is going to be horizontal. If it's horizontal, then this is the equation I need to work with, right? So my equation is x minus h squared over a squared plus y minus k squared over b squared equals 1. That's the thing I need to use to help me, because I'm going to have a horizontal major axis. Now, the other thing that I know. What's the other thing that I know here? Well, I've got my foci, and I know that the length of my major axis is, 6. So since the length is equal to 2a, I can say that 2a equals to 6, which means that a is equal to 3. So the other thing I know is that my a is 3. Okay, so I guess I'll do that in purple. But remember what a is, and I left this here for a reason. A is the distance from the center to a vertex, right? Well, I don't even know what my center is. Oh, but that's easy. If this is a focus and this is a focus, we know that the center has to be right in between, the midpoint between those two. So technically speaking, all you have to do is subtract the x-coordinates of the focus and divide by 2. Right? So remember, this is the point 0, 1, and this is the point 4, 1. So if I subtract, if I do 4 minus 0, and that's 2, and divided by 2, then my center is going to be on this line, but at 2, 2. So my center is going to be right here. Sorry, 2, 1. All right, so I have a center, I have the 2 foci, and now I've got to find, let's see, I've got A, and I need to find B because I'm going to have to find my minor axis, and anyway, I know what my C is, maybe, right? I do know what my C is. My C is 2. What is C? C is the distance between the center and the focus, right? So this distance right here is your C. And just remember that this is a horizontal distance, and so if you do 4 minus 2, in other words, you're subtracting those x-coordinates, you're going to get your C. So 4 minus 2 is 2. So I know that C is equal to 2. So I have an A, I have a C, and I need to find B. Well, what's the formula? The formula says A squared is equal to B squared plus C squared. Okay, well, 3 squared is equal to B squared plus 2 squared, right? So solving for B squared, we have 9 minus 4, so B squared is 5, which means that if I take the square root of both sides, I get B is equal to root 5. Now, I don't know what root 5 is. I know it's 2 point something, right? But that's okay. Let's see, I did this in green. I know from the center, if I go root 5 above and below, or 2 point something, 2 point, what is root 5? It's 2.236, so I'll say 2.2-ish, okay? So if I go a little more than 2 above and a little more than 2 below, that's going to be, this right here is going to represent my minor axis. Now, I haven't found the vertices yet, right? So let's see, the vertices, we're on a horizontal major axis. So it's going to be the center, the x-coordinate of the center plus or minus A. So my vertices is going to be H, which is 2. Remember, this is HK right here, right, the center. So it's 2 plus or minus A. Well, A was 3, comma, K. Well, K is just the y coordinate of my center, which is 1. So what I'm going to have is 2 plus 3, or 5, comma 1, and 2 minus 3, which is negative 1, comma 1. And those are going to be the coordinates of my vertices. So my vertex is going to be over at, I need another mark here, and throw a few more there. So my vertices are going to be at 5, 1, and negative 1, 1. Okay, so I'm going to try and put this together, but you know I cannot draw. Yeah, this is pretty sad looking ellipse. There's my ellipse. Did I find the equation? Heck no. But we need the visual, right? So let's find the equation. Okay, I know my center. So let me just write this. Let me write this here. My center was at 2, 1. Okay. A was 3. B is root 5. My C was 2. So now I'm just going to plug everything into here. So I'm going to have x minus 2 squared over a squared. Well, a squared is 9. Plus y minus 1 squared over, and that's a 9 by the way, not an a, over b squared. Well, the square root, the square root of 5 squared is just 5, is equal to 1. And that's the equation in standard form of that ellipse.